we now discuss the solution of a problem from the section Differential Calculus. The given question is on an indeterminate form. This question has appeared in the joint entrance examination main held on 26th June 2022 in the second shift. And this question is also suitable for Telangana State MSET and Andhra Pradesh State EAP CET aspirants also. The given question is limit x tends to 0 cos of sin x minus cos x by x to the power of 4 is equal to. We are given four options. Option A 1 by 3, option B 1 by 4, option C 1 by 6, option D 1 by 12. That is the given question to us. Let's now discuss the solution of the problem in detail. We have the given limit. Now, observe that as x tends to 0, the numerator cos of sin x minus cos x tends to 0, and the denominator x to the power of 4 tends to 0, and hence it takes the form 0 by 0 form, which is an indeterminate form. Now, to evaluate this, we do in the following manner. Now, let's take the limit x tends to 0 cos of sin x minus cos x by whole by x to the power of 4. The numerator, if you see, it is of the form cos c minus cos d. We have a formula, we recall it. Cos c minus cos d is equal to 2 times sin of c plus d by 2 into sin of d minus c by 2. Sin of d minus c by 2. So now that is equal to limit x tends to 0, 2 times sin of c sin x d plus cos x, that is x plus sin x by 2 into sin of d minus c. D minus c means x minus sin x by 2 whole by x to the power of 4. To evaluate this, so we take, we manipulate, we multiply and divide by suitable factors. Now, this is equal to 2 by x to the power of 4 we have taken, and we have multiplied and divided by the factors x plus sin x by 2 into x minus sin x by 2, and we multiply and divide. That we write it as limit x tends to 0 of 2 by x to the power of 4 sin of x plus sin x by 2 by x plus sin x by 2 into sin of x minus sin x by 2 by x minus sin x by 2 into, they are compensated now, x plus sin x by 2 multiplied by x minus sin x by 2. And the limit of the product is equal to product of their limits. So that will be equal to limit x tends to 0 of sin of x plus sin x by 2 by x plus sin x by 2. That's the first one. Multiplied by the second one, limit x tends to 0 sin of x minus sin x by 2 by x minus sin x by 2. Agreed. And x plus sin x into x minus sin x is x square minus sin square x by 4. And there is already a 2 by x to the power of 4. 2 cancels. And you will get x square minus sin square by 2x to the power of 4 as limit x tends to 0. Agreed. And as limit x tends to 0, this is 1. And limit x tends to 0, this is 1. Why? It is of the form limit x tends to 0 sin x by x. That formula we are using. And it is 1, this is 1, this is 1. So you are left with limit x tends to 0 of x square minus sin square x by 2x to the power of 4. Now, we continue the discussion in the next slide. So, we have the given limit x tends to 0, cos of sin x minus cos x by x to the power of 4 is equal to limit x tends to 0, x square minus sin square x by 2x to the power of 4. Now, we observe as x tends to 0, numerator tends to 0, the denominator tends to 0, and hence it takes a 0 by 0 form, which is an indeterminate form. The method 1, I will show you in two methods. This is the method 1 and the method 2 I will show you after this. In the method 1, so we use the L'Hopital's rule, the so-called L'Hopital's rule repeatedly. The L'Hopital's rule, please spell it as L'Hopital's rule. Now, limit x tends to 0 of this is 0 by 0 form, which is an indeterminate form. We use L'Hopital's rule. So, limit x tends to 0, the derivative of this numerator by the derivative of the denominator. That is, limit x tends to 0, the derivative of the numerator is 2x minus 2 sin x cos x by 2 into 4 x cube. We have used LHR, means L'Hopital's rule, that is L'Hopital's rule. Now, this we write it as limit x tends to 0, 2x minus 2 sin x cos x we have written as sin 2x, and 2 into 4, 8x cube. Now again x tends to 0. So as I have told you that we will be using L'Hopital's rule repeatedly. Normally a student follows this kind of a method. And now it takes 0 by 0 form. Again differentiate numerator, that is 2 minus 2 cos 2x, yes, by 8 into 3x square, correct, by L'Hopital's rule. Now the numerator, limit x tends to 0, numerator is 2 into 1 minus cos 2x by 24x square. 1 minus cos 2x is 2 times sin square x, and that is equal limit x tends to 0, 2 into 2 sin square x by 24x square, and 2 into 2, 4 by 24 is 1 by 6, and limit x tends to 0, sin square x by x square, that is limit x tends to 0, sin x by x whole square. And as x tends to 0, sin x by x takes the value 1. So you will get 1 by 6 as the answer. So the limit x tends to 0 of the given function is 1 by 6. That's our answer. Let's go to the method 2. So in this method 2, we have already observed is a 0 by 0 form. Agreed. Now limit x tends to 0 of x square minus, for sin x we have written its Maclaurin's expansion. The Maclaurin's expansion for sin x is x minus x cube by 3 factorial plus x to the power of 5 by 5 factorial minus so on so forth whole square. Agreed. By 2x to the power of 4. We have used the Maclaurin's expansion of sin x. Now limit x tends to 0, x square minus, in this there will be higher powers of that, but we will concentrate only on the first two terms, and that is equal to limit x tends to 0, x square minus in brackets. So think as if two terms are there, x minus x cube by 3 factorial whole square is x square minus 2 into x cube by 3 factorial, that is minus 2x to the power of 4 by 3 factorial plus x to the power of 6 by 3 factorial whole square plus the higher powers of x. The higher powers of x higher than x power 4 and x power 6. Agreed. Now take out the bracket now. So limit x tends to 0, x square minus x square cancel, x square minus x square cancel, and that will be minus into minus plus 2x to the power of 4 by 3 factorial minus x to the power of 6 by 3 factorial minus the higher powers of x by 2x to the power of 4. Now in the numerator take a x to the power of 4 common, and in the denominator x to the power of 4 is that. Then you will have limit x tends to 0, 2 by 3 factorial minus x square by 3 factorial square, yes, 3 factorial square minus the higher powers of x. Now as x tends to 0, it is 2 by 3 factorial by 2, that is 1 by 3 factorial, and this will be 0, and that is 1 by 6. Let's look at our options. Our answer 1 by 6 appears against option C. Therefore, the answer for this question is option C. That is the detailed discussion of the solution of the problem, which is on an indeterminate form from the differential calculus. I am sure that you appreciate that I have shown this, the evaluation of the limit by two methods, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.